Hi students. Hope you're doing good and enjoying your studies. So today, EdFalco Academy is bringing to you a demo class for class 9th mathematics. Um, Before we start on the topic, a little bit about EdFalco Academy. We are an epitome of Faro education, which we take pride in calling it as faster, affordable, um, uh, result-oriented, and accurate education. Um, and before we start, let me introduce myself. Myself Nishant from IIT Madras with 14 years of industrial experience and also more than 7 years of experience in teaching. So today I have selected a topic for class 9th, which is a well talked about topic, and that is polynomials. And I will discuss a little bit about polynomials. We can't do everything in this demo class, but definitely we will talk a little bit about polynomials and then we will go on discussing about remainder theorem, which is also an important topic for class 9th. So yeah, at any point in time, if you feel any difficulties, any questions, you can obviously reach back to us. You can call us on our number. You can reach to us or contact us through email empower@falcoacademy.com, or you can also visit our website. So without much ado, let's start the chapter on polynomials and then discuss about the remainder theorem. So we'll discuss about the topic polynomials. So the first question is obviously what is a polynomial, right? And so polynomial is nothing but uh, you have already studied in your eighth standard about the expressions and terms, right? So the polynomial is nothing but the accumulation or bringing all the terms together and utilizing some operators, mathematical operators, in order to separate them. So you already know that there are four different operators in mathematics, right? One is in broadly, I can say, one is addition, one is subtraction, multiplication, and then division. Obviously, when we talk about terms, just to give a brief refresh about what we studied in class 8. So when we discuss about terms, generally the terms, if are considered to be one term itself, if they are considered single term, if they are if the variables or the constants are put together in a multiplicative or division way, they will be called separate terms provided they have a positive they have a addition or subtraction operators in between. So what I mean to say by that is 2x into 3y. Suppose you understand here that there are two variables, one is x and another one is y. So now 2x into 3y, can we call it a one term, or do we consider it has two terms? So you all know that it is nothing but it has one term. And why it has one term? Because it's simply a multiplication. The 2x and 3y are basically happening as in the multiplication. It could have been 2x by 3y also. It would have been considered as a single term, right? That's also a one term only. But if we consider 2x plus 3y, then there is an operator coming in between, which is plus operator, right? And it could be also 2x minus 3y. Similar way, a minus sign is coming. So whenever there is a separation of terms with plus or minus sign, we can consider them as different terms. So in this case, if I write 2x plus 3y, these are two different terms. Obviously, there are two variables, so it's two terms with two variables. But even if it was a single variable, for example, if it was 2x plus, let's say, 5x square, still there were two terms because they were separated by a addition sign. And same way, like if you take, let's say, 2x square plus 5x minus 6, this also has This also will be having three terms, because here also there are two operators, plus operator and a minus operator. So therefore it will be considered to have three terms. One is 2x square, one is 5x, and one is 6. So I hope this is clear. This we already had studied in 8th standard. So nothing much to talk about it here. We can always revise it. And another thing that I wanted to bring an attention on is, let's also talk about or get ourselves refreshed about the different terminologies that are used. So let's pick up one expression. For example, let's say 5x square plus 3y plus 8. Now, suppose this is an expression that we have picked up. So there are a couple of things that are associated with this expression. One is the constant that is getting multiplied. So obviously, first of all, we have to find out how many variables are there. So you can see here there are two variables that are present, x and y both, right? So there are two variables. This is a two variable equation, first of all. We are not going to study two variable equations when we are studying polynomial, but just for explaining the polynomials, and I'm letting you know that it can have two variables also. So this is the case where we are having two different variables, x and y. Although we are not going to study that kind of a polynomial. We will study only those polynomials where there is just single variable involvement. So either x or y will be involved. So it will be a single variable. But here it's the case of two variables. So we have two variables here, x and y. Now the another important thing is about the terms. So as we just talked about the terms, there are three terms because they are separated by a positive sign. So there are three terms. Now you can see that so three terms. That's another important thing that we need to understand. And then another important thing is that there is a constant getting multiplied by the variables. So for example, in the first term, you see there is a constant 5 which is getting multiplied with x square. Same way, if you look at another one, in this scenario, you see there is a 3 getting multiplied with y. So and then there is one which is a constant. It's a constant term. So this one is a constant term. It's called a constant term because it doesn't has any variable with it associated with it. Here it's here with y there is 3 associated, and what do we call this 3? This will be called the coefficient of y. Coefficient of y. Same way, this 5 will be called the coefficient of x. So you understand here that the terms that are getting the constants that are getting multiplied with the variables in a given term, they are the coefficients. They are being called as the coefficients. Another important aspect to understand is about the power. So here you see that x has got the power 2. Y has just got the power. How much is the power in y? Y power is basically 1, because we can write obviously y as y to the power 1. Y to the power 1 is nothing but y. We all know that. So the power of y is 1. Now there is a question for you, that what is the power of variable x and y in the constant? So you might be thinking that since it's a constant, there cannot be a variable associated with it, right? But that's not true. So let's look at y. So 8, that was a constant, can obviously be written as 8x to the power 0, y to the power 0. Now you know that anything that is raised to the power of 0, for example, 5 to the power 0, it is 1. 8, you take 10 to the power 0, that's also 1. Any number, if you take x, y, or whatever variable you want to take, the value of anything raised to the power 0 is nothing but 1. So here 8 can be written as 8 into x to the power 0 into y to the power 0. Why? Because x to the power 0 is nothing but, basically it is 1, and y to the power 0 is also 1. So you are basically doing 8 into 1, which is nothing but 8. Right? So therefore, the power of variable x and y in the constant 8 is basically 0 and 0 respectively. Okay, so with this as the understanding, let's move on and try to understand. Now, the next important question that we should try to answer is whether whether the given expression is a polynomial or not. Polynomial or not. This is an important question, right? We should be knowing that whether the expression that is given to us is a polynomial or whether it's not a polynomial. So, like, for example, if I tell you an expression, let's say minus 3 root x plus x to the power 1 by 3 plus 8x cubed. Now, whether this is a polynomial expression or not. Obviously, now here you can separate it out that you have three terms. First of all, there are three associated terms. Minus 3 root x is first term, second term is x to the power 1 by 3, third term is 8x to the power 8x cubed. The coefficient associated with root 8 is minus 3. The coefficient associated with x to the power 1 by 3 is nothing but 1. It is 1 into x to the power minus x to the power 1 by 3. And the coefficient associated with x cube is definitely nothing but 8. So we are clear with all this. But there are certain rules that whether we can call it a polynomial or not. So what are those rules? That's important to understand. So the first thing is that the power of x or any variable, power of variable, it cannot be negative number, it cannot be a negative number, or it cannot be a fraction. So this is an important thing that we cannot take a expression with a power of x or y or whatever the variable that is present in that expression as a negative or fraction. If that is the case, then that particular polynomial will not be counted as a, if then that particular expression will not be counted as a polynomial. So it means you can directly see that there is a violation here. X to the power 1 by 3. 1 by 3 is nothing but a fraction. Same way root x. Root x is nothing but x to the power 1 by 2. We all know that, right? So x to the power 1 by 2. Again, you see it is 1 by 2, which is nothing but a fraction. So in this case, since this term, the first term, the second term, both are having negative, are having either negative number or fraction. In this case, it is fraction. Therefore, it is not a polynomial. It is not a polynomial. So, although the third term, 8x cube, is behaving like a polynomial term, but overall, if the expression is asked, the expression itself in holistically is not a polynomial. Just even if one of the terms is not a polynomial, the overall expression becomes a non-polynomial equation. So the thing to remember here is that the power of the variable cannot be negative number. So I cannot have like 8, I cannot go and have like 8x to the power minus 3, which means it is 8 by x cube. This is not a polynomial. 8 by x cube. This is not, sorry, this is will be 8 by x cube. So this is not a polynomial. This is not a polynomial, right? I hope this is clear now. Now, another important thing to understand before we proceed further or we move away from this polynomial thing is understanding um, about the about the number of variables. Number of variables. So a polynomial can have one variable, two variables, or multiple variables, right? It can have multiple variables. So it can have just x as the variable, which is just single variable. So it's a single variable equation, which means expressions like 5x square plus 2x plus 5. It's a expression, it's a expression. Each of the term does satisfy the rule of being a polynomial. They are neither they don't have either a negative power or a fraction. It's a whole number. So that way all the terms are belonging to the polynomial category. So the entire expression is a polynomial. So that is fine. But also important thing is that only x variable is associated. So there it is just a single, it's just a single variable equation because we don't have any other variable, we have just x. If there was another variable associated, for example, if it is a two variable equation, then we would have 5x square plus let's say 2y plus 5. So in this case, this is a two variable expression, this is a two variable expression, right? So that kind of expression will be called a two variable expression. So now, in as far as our understanding is concerned, or what is there in our syllabus, we just have to study the polynomials which are single variable expressions. So either they will have y or x, not both, right? Only one variable will be there. And also, um, the other important thing to understand is about the degree of the polynomial. Degree. What is the degree of polynomial? So degree of polynomial is nothing but the highest power of the variable, highest power of the variable in that expression. So let's say I have the expression 8x to the power 5 plus 3x cube plus 7x plus 9. This is the expression given to me. So you can see here that first of all, it is a polynomial. We have to check first of all that whether it's a polynomial or not. So we see that everything has the powers which is not negative or any fraction number, and therefore it's obviously a uh, uh, it's obviously a polynomial. Now the another important thing to understand is that it is single variable polynomial because only x is involved. And how many terms are there? There are four terms. Now, what is the degree of this polynomial? The highest power of x, if you count here, the power of x here is 5, right? This 5. Here the power is 3. Here the power is 1. And what is the power of x here? It is 0 because we just talked about that 9 can be written as 9x to the power 0, right? In just the previous few minutes back, we were discussing this. So the power is 0. So out of this 5310, what is the highest power that it has? So we can say 5 is the highest power. So this is a polynomial with degree 5. It's a polynomial with degree 5. With degree 5. So I think all the terms that are associated with the polynomial is now clear to us. We have understood what is the term, what are the different terms of a polynomial. We have also understood which one is a polynomial, which equation to be called a polynomial, which expression to be called a polynomial, which we cannot call as the polynomial. That is second thing that we understood. Third thing, we also understood that what is a single variable polynomial, right, which has only x. There is no involvement of any other variable. That is single variable polynomial. And then we also understood what is the degree of the polynomial. So the degree of the polynomial is the highest power of that particular variable in the expression that is given. So with this understanding, and the terminologies are also now clear to us. So with this understanding, what we have to study is, or we have to concentrate on, is basically single variable polynomial, single variable polynomials, which means the degree of this polynomial can be anything, but it has just one variable associated with it, which is either x or y or whatever. So let's call it x. Uh, Only x is associated in this entire expression. Now, based on the number of terms, we can have, as we saw, we can have just one term, we can have two terms, we can have three terms, and so on, right? It can have a number of terms. If it has just one term, we call it a monomial. Monomial. Mono means it stands for one. So it's just a one term single variable. Obviously, everything is single variable. We are not talking about anything else. Inside the single variable polynomials, the number of terms is one, which means we will call it monomial. Same way, if there are two, we will call it binomial. We call it binomial. So what is an example of a monomial? It can be like 3x, 7x. It can also be like 8x square. So just one variable, right? Just one, sorry, just one variable and just one term. right? Degree is immaterial. It can have multiple, it can have higher degrees also, like you saw, you can see here it is degree of 1, here you see it is a degree of 2. So that's fine, but it has just one term, either it is 3x or it is 8x squared. Now in a binomial there will be two terms, so which means it can be something like 2x squared plus 5x, which has two terms here associated. So one is 2x squared, another one is 5x. Same way we can have trinomial for 3 and so on, right? And now based on the degree also we have, if it's just a 1 degree equation, right? So if it's a 1 degree polynomial means what? What would be an example of that? Like 5x plus 3. We see there are, so here we are not counting the number of terms. Let's say it has 5x plus 3 plus 8 plus 7x, whatever it is. So however, the number of terms is not important. We are looking only at the from the degree point of view. So based on the degree, you can see the highest power of x is 1 here. So when the power or the degree is 1 for a polynomial, like for example 5x plus 3, we call it a linear equation, linear polynomial, linear, right? And when the degree is 2, so what will be the example? It could be anything, something like you can say 2x square plus 5x plus 6, for example, 5x plus 6. So this can be an expression where we have three terms. So again, number of terms is not important, but one important thing is um, you can directly see that if it has a degree n, if it has a degree n, for example, here the degree is 1. How many terms we are able to get? We are able to get two terms only. So even if suppose you wanted to make more terms, for example, if with a degree of 1, you wanted more terms like 5x plus 8x plus 3x plus 6 plus 5 plus 4. You cannot have anything greater than the x to the power 1, right? Otherwise, the degree itself will change. So the maximum things that you can have is either you can have a constant which will have the x power as 0, or you can have something like x to the power 1. So suppose if you have so many terms, 1, 2, 3, 4, 5, 6, but still you can see that most of these terms will be like terms. Like these terms are basically like terms, and they can be ultimately added together. So 8 plus 5 is 13, plus 8 plus 5 is 13, plus 3 is 16. So 16x, ultimately it will become 16x. Same way, these three terms are like terms, right? Because they have the same power, and of x, it is x to the power 0, right? So these are the, again, the like terms. So that means 6 plus 5, 11, and 11 plus 4, 15. So ultimately, you are going to get 16x plus 15, right? So you will be reduced to two terms when the degree is 1, when the n is 1. You are getting how many terms? Two terms. Same way, if you look at when the degree is 2, when the degree is 2, you cannot have more than three terms. For example, if suppose you wanted 5x square, you also wanted, let's say, 2x square, right? Or you wanted, let's say, 7x plus 2x plus 5 plus 1. That is the maximum that you can do, right? You cannot go beyond x square, because otherwise the degree itself will change. And now, however terms of x square you write in the expression, all of them will be basically like terms and they can be added together. So you will have one term that is maximum possible for x square, because all the terms, even if you have written it in different ways, can be ultimately added together because they will all be like terms. So for example, you see here 5x square plus 2x square, it will ultimately become 7x square. It will convert to just one term, which is having the power of 2 for x, right? Same way for power of 1, 7x, 2x, or even if you would have something else, like 2x or maybe 5x, again, all those would be like terms and it will get added together. So 7 plus 2 in this case is nothing but 9x. So ultimately it converts to one term, right? And same way, the constant also has a power of x to the power 0. It will also convert to one single term because again, all of them will be like and they can be added. So here 5 plus 1 can be added to give 6. Ultimately, you see you are ultimately being reduced to 3 terms, right? So when the degree is 2, you are reducing to 3 terms. So that's where if the degree is n, you cannot have or you cannot have more than n plus 1 terms. You cannot have n more than n plus 1 terms. So the maximum number of terms that you can have, maximum number of terms that can be present in a polynomial of degree n will be n plus 1. And how we will visualize that, how we will see that what I'm saying is correct or not. So let's say if I have a degree of n, right? The polynomial of a degree n. The polynomial has the degree n. So in this case, I can have one term which is associated with x to the power n. And it will have obviously some constant associated, as coefficient associated with it. Let's call it a, capital A. So capital A is the coefficient associated with x to the power n. Then it will have x to the power n minus 1, right? For example, if n is 3, you will have x to the power 3, and then x to the power 2 can also be present. Obviously, it will also have some coefficient associated with it. Let's call it b. Same way, c, x to the power n minus 2. And same way, it can keep on continuing till you get finally something like, let's say, whatever it comes, a1, let's call it a1 as a final, as a constant, x to the power 1 plus finally a2 as the last constant, which has x to the power 0. So how many maximum terms we are getting? We are getting basically from x to the power 0, x to the power 0 to x to the power n. So how many terms are there? Each one is being counted as one term, right? X to a2, this is one term. X to the power 0, this is one term, right? So if you count all this, there will be n plus 1 terms. So how many numbers are between, let's say, 0 to n, right? That's the question, simple question. So there are n plus 1 numbers, and therefore there will be n plus 1 terms. So a polynomial of degree n will have n plus 1 terms. So I think we have discussed about most of the things about the polynomials. Sorry. So most of the things we have discussed now. Yeah. So now let's move on to a general form of polynomial. Since we have to study only, we have to study basically the single variable polynomial, right? So, and we have also seen that a polynomial of degree n can be, will have maximum of n plus 1 terms. By the way, this is the maximum number of terms. Some of the terms may be missing also. So, for example, if suppose I have the expression something like 5x cube plus 2x, right, plus let's say 1. This is my expression. What is the degree? Obviously, the degree is 3. But you would say that that means that it should have 4 terms, right? It should have 4 terms maximum. 4 terms max, right? So if the degree is 3, which means if n is equal to 3, I should have maximum of n plus 1 terms, which means I should have maximum of 4 terms. Now here we are seeing that there are just 3 terms. Where is the 4th term? So the thing is that the coefficient of the 4th term is basically 0. So this expression is nothing but 5x cubed plus the x square term is missing, which means it is getting multiplied with 0 x square. So obviously 0 into x square is nothing but 0. That's why it doesn't appear here. So the coefficient of the x square is basically 0. That's why it has got omitted from this expression. And then basically it is 2 into x to the power 1 and plus 1 into x to the power 0. So there are basically 4 terms only if you look at it. There are four terms as per our understanding. The maximum of 4 terms are possible. Maximum of. But here this term is getting omitted because it has the coefficient of 0 associated. And therefore it doesn't appear in the final expression. So it can have, so when we say that there will be n plus 1 terms, we are not saying that it will always have n plus 1 terms. N plus 1 is the maximum number of terms that it can have. Obviously, that it can have lower than n plus 1 also, but it cannot go beyond n plus 1. It will be always either n plus 1 or it can be below n plus 1. That's one thing I wanted to explain. So now let's move on. Let's move on to the general form of a polynomial. So in single variable, because that is what we have to study, right? So in general, a polynomial of single variable in degree n, as we saw, it can be written as a naught. A naught is just something like a coefficient. It's a constant. A naught x to the power 0, right? Plus a1, again a1 is some other constant, x to the power 1 plus a2 x to the power 2. A2 is again some another constant, plus which is a coefficient of x to the power 2 basically. A3 some other constant, x to the power 3. Similarly, we can keep on doing this till an. An is again a constant number, x to the power n. So this is the polynomial of x of degree n, right? It's a polynomial x of degree n. So obviously, as you understand that degree n will have n plus 1 terms, you can see that there are n plus 1 terms starting from x to the power 0 going all the way to 1, 2, 3 and till n. So that means there are indeed n plus 1 terms that are associated here. N plus 1 terms are present here. So that's one thing. And second thing is, in general, each of this powers of x, whether it's x to the power 0 or whether it's x to the power 1, x to the power 2, 3, or x to the power n. Each of them has their own coefficients. So a naught, a1, a2, a3, an are basically representing the coefficients of this coefficients of each of those x to the power uh, um, x to the power something, which is between 0 to n, of course. And since it is going up to n, therefore it's a polynomial of degree n. The maximum power is going up to n, therefore the degree is basically n. So this is the general form of the expression. Now, obviously, there can be certain coefficients like a1 can become 0 or a2 can become 0 or any of those can be 0 or multiple of those can be 0, right? But all of them cannot be 0. So one thing is important, that if the polynomial is of degree n, if we have told that this polynomial is of degree n, right, then obviously an to the power x to the power n, this term must exist. Even in the as a minimum case, at least this term has to be there. Then only it can be called as a degree of n. If this itself is not there, then obviously it means that there is the degree itself has got reduced than n. So therefore, it cannot be called as n degree equation itself. So if the degree of the polynomial is n, this term must be there, plus all other terms like as we saw an minus 1 x to the power n minus 1 plus dot 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 plus till a1 x to the power 1 plus a0 x to the power 0. All these are not mandatory to be present. Not mandatory. They may be present, they may not be present, depending upon their coefficient. If their coefficient is 0, that term will vanish, right? Otherwise, they will be present. So that's a general form of the polynomial in single variable. So we will discuss this chapter in more detail and more depth when we are discussing further during the classes or during the online lectures. But this is a demo class and just giving a brief understanding of the various topics that are covered. So as I told, now we will move on. I have explained pretty much most of the things involved in the polynomial expression. Now I will be going into and explaining about one of the topics which we call as the remainder theorem, and this is also associated with polynomials. Remainder theorem. Now, what is remainder theorem? So remainder theorem basically says that if there is a polynomial p of x, it can be any polynomial. You saw that the general degree of the general expression for the polynomial you have already seen. So any polynomial, let's you can think of a polynomial like 5x cubed plus 2x square plus 7x plus 10 in your mind, or anything like that. So if any polynomial px is getting divided by a linear polynomial means the power is only 1. So what is the, in general, what could be the linear polynomial? It will be x minus alpha or x minus a. Let's call it a, x minus a. So any polynomial p of x is getting divided by a linear polynomial which is x minus a. What the theorem says is that the remainder that we will get, the remainder that we will get will be basically equal to, in the polynomial, if we put the value of a, so basically equate this to 0, equate this to 0. That means if you make x minus a is equal to 0, x is equal to a basically, right? X will become equal to a. And with that x, you put the value of a in this polynomial p of a. So instead of x, put a. So whatever that p of a is giving you, that will be the remainder of this expression, of this division of px when we are doing the division with x minus a. So okay, let me explain this in uh, with an example. So let's say I have the polynomial which is given by, let's say, 5x cube plus 2x square plus 7x plus 2. Suppose I have this as the polynomial, and it is said that we are going to divide this px, or divide this polynomial by a linear. So it is very important. This is, we are talking only about the linear as of now. We are not talking about any other sort of division. When we are talking about this division, we are only considering linear expression or linear polynomial. So it is going to be divided by a linear polynomial, which, let's say, it is x minus 2. This is the polynomial x minus 2, x to the power 1, so it's linear, right? It has a degree of 1. So it is going to be divided by x minus 2. And then what we have to find is what will be the remainder. What will be the remainder if I divide this polynomial with this particular linear polynomial x minus 2. So first of all, let's see what it is telling, what the theorem is talking, and then we will try to understand that what is the proof of all this. So, sorry. So now this is the question, that if this polynomial is to be divided by this x minus 2 linear polynomial, what will be the remainder? So what the theorem is telling is, you equate x minus 2, that is from the polynomial uh, which uh, which is basically the divisor, right? So it is going to divide that px polynomial. So x minus 2 is the polynomial which we should be equating to 0 first, and see what is the value of x coming out. So x is coming out to be 2. If you equate x minus 2 to 0, you will get x is equal to 2, right? So it's simple. You will get x is equal to 2. Now the remainder, when this x minus 2 is dividing p of x, the remainder is nothing but p of 2. What is the meaning of p of 2? So in the polynomial, we will substitute the value of x as 2. And how did we get that 2? By equating this x minus 2 to 0. So we got x should be 2. So now what I'm going to do is I'm going to put the value of x, replace the value of x with 2 in for the polynomial px. So it will be 5 into 2 cube 5 into 2 cube because x cube is there, plus 2 into 2 square plus 7 into 2 plus 2. That will be the value of the polynomial at x is equal to 2. So now this will become what? 5 into 2 cube is 8 plus 2 into 2 square is 4 plus 7 twos are 14 plus 2. So this is going to give 8 fives are 40, 8 fives are 40, 2 fours are 8 plus 14 plus 2. So how much does it come? It comes 40 plus 8 is 48. 48 plus 2 is 50. 50 plus 14 is 64, right? Just check that I have done it right. 40 plus 8 is 48. 48 plus 48 plus 10 is 60. 14 is 62 plus 2, 64. So 64 is the value of this polynomial at x is equal to 2. And what this theorem is telling, that remainder will be nothing but p of 2, which is coming out to be 64. So 64 is the remainder that we are going to get, provided we divide this polynomial with x minus 2, the given polynomial by x minus 2, with x minus 2. Now let's see what is the proof of this. So in order to understand the proof, we will look into the basics of how the division is generally done, right? And then we can discuss about why this is happening. So suppose you already know from your very basics, or from your lower classes, that while doing the division, what we generally do, we keep, if we have to divide one polynomial with the other linear polynomial, x minus 2 will be kept here, right? And the polynomial p of x, that whatever that polynomial was given to us, right? 2x, what was that polynomial? 5x cubed plus 2x square plus 7x plus 2, right? This was the polynomial that was given to us. So this polynomial will go over here, right? In the as the polynomial that is to be divided. Now, after we do the division, all that we generally do, what we are going to get? We are going to get a remainder. And one more important thing here: whenever you divide with a linear polynomial, you are going to get a remainder which is constant, which is 1 degree lower than whatever the polynomial with which you are dividing. So if you are dividing this with x minus 2, that means what is the degree of this? The degree is 1. So the remainder that will come will have the degree 0. If suppose you were dividing with x square minus 2, that means the degree was 2, your remainder will have degree 1, which means it will be of the form ax plus b. Okay, this is also an important thing. But anyways, we are not discussing about the division with 2 degree polynomial. We are only restricting ourselves with the polynomial of degree 1. But this is an important thing to understand, that if we are dividing it with a polynomial of degree n, which means, for example, if it is x minus 2 that we are dividing with, so the degree is basically 1. So in that case, the remainder will have 1 degree lower, which means it will have degree 0. And what does degree 0 mean? Degree 0 means it will be a constant, because we have seen, suppose 5 is the number, right? A constant number. The degree of 5 is what? The degree of 5 is 5 into x to the power 0. So the degree is basically 0, right? So it will be a constant when it is going to be divided by a linear factor, which is x minus 2, or a linear polynomial. If suppose it was going to be divided by, or it was told that we had to divide this with a polynomial with a degree 2, for example, if it was x square minus 2, then the remainder that would have come would have not remained constant. It would have been a remainder, or a polynomial with a 1 degree lower, which means it would have been with degree 1. And degree 1 means it should have something like ax plus b form, right? Some constant multiplied by x to the power 1, which means ax, and plus some other bx to the power 0. So that could have been the form of the remainder. So we are not currently talking about that. We are only talking about the case where the remainder is going to be a constant, and for that the polynomial which is going to divide is a linear polynomial. For example, x minus 2, which we know is a linear polynomial that is given to us over here. Okay, so with that understanding, we are going to divide it with x minus 2. So after doing the division, we will get some remainder, and we know that this remainder is going to be a constant number in this particular case, given the fact that this is a linear polynomial, right? It is x power 1. So, and the other thing that we get is some polynomial we will get, let's call it q of x as the quotient or the quotient that we call, right? So that is how the general division happens, right? And now, how do I get back px? If I have to get back px, I can always say that px is nothing but if I multiply my quotient with the polynomial that I was going to, that I divided it with, that means x minus 2, and add the remainder to it, I should get the value of px, right? Simply, it is simple to understand. Suppose if you are dividing a very simple number, let's say 9 with 2, right? So how many times it will go? You know, it will come 4 over here, and minus 8, you will get 1, right? 1 is remainder, 4 is quotient, 2 was the divisor, and 9 is the dividend, right? So you can always get 9 like, how you can get 9? You can get it like 4 into 2, 4 into 2, which means you are multiplying the quotient with this divisor, right? And then plus 1, which is the remainder. So you are going to get 9. The same thing I have done here. The quotient is to be multiplied with the polynomial that had divided this particular polynomial px. And then if I add remainder to it, I should get back p of x, which is the original polynomial which was to be divided. So therefore, we have this expression p of x is equal to q of x. Q of x is the quotient polynomial multiplied by x minus 2 plus the remainder. Now, if I have to if I make x minus 2 as 0, if I make x minus 2 as 0, what is going to happen? This term over here, since I made this as 0, this as 0 multiplied with q of x, this entire term is going to vanish, right? This entire term is going to vanish. So when I'm making q minus 2 as equal to 0, this entire term will vanish, and what will happen? That I will get p of x is nothing but equal to r. And now when I make x minus 2 as equal to 0, I will get x is equal to 2, right? So and how do I make that x minus 2 as 0? Okay, I told that I will make x minus 2 as 0. How do I make x minus 2 as 0? By taking x is equal to 2, right? If I put x minus 2 is equal to 0, I will get x is equal to 2. So the moment I substitute x as 2, so p of 2 on the left hand side is equal to q of 2 into 2 minus 2, which is x minus 2 plus r, right? So 2 minus 2 becomes 0. This entire term becomes 0. So we get p of 2, we basically get p of 2 equal to r, and that's what we are seeing, that if we equate x minus 2 to 0, we get x is equal to 2. If we just put 2 value for in the polynomial, what we will get is basically the remainder. That's what the theorem was telling, the remainder theorem was telling, and that's what we can see from here as well, that why it is happening. Now it doesn't matter in general, if I have to talk, it doesn't matter whether it is 2 or 5. If suppose a polynomial px is to be divided by a linear polynomial x minus a, where a can be anything, right? What the expression will be is basically p of x after division. It will be p of x is equal to some quotient of x into x minus a plus r. That is how I will write it, right? And once I write it like this, the moment I make x minus a, sorry, x minus a, x minus a equal to 0, and I take x is equal to a, I take x is equal to a and substitute back in this expression. X minus a minus a will become 0. This entire expression will become 0. And I will get p of a is nothing but r. So I will just need to substitute the polynomial that with which the division was to be done. I will just equate it to 0. I get the value of x. And if I just put that value in the polynomial, substitute that the value of x with the value of a that I am with the value of a, I will get the remainder that should be actually happening when this polynomial is actually being divided by x minus a. So that is what this remainder theorem is telling in short. So now let's move on to some questions. So few simple questions we will do, and then we will wrap it up, and we can take the more detailed and tougher questions as we in our classes, or when we are doing the online classes, can discuss more of these problems, more of this kind of difficult level problems. But here let's discuss one simple problem. So for example, um, a polynomial a polynomial 3x square plus kx plus 8 is when divided by when divided by when divided by, let's say, x minus 2 leaves 3 as remainder. So find the value of k. Find k. So the question is telling that we have a polynomial which is 3x square plus k times x plus 8. K is a coefficient basically, and it is going to be divided by x minus 2. And then once it is divided, it leaves the remainder 3. So in that case, what will be the value of k? So as we saw in the remainder theorem, that we we will equate simply x minus 2 to 0, right? Because why? Because we know that 3x square plus kx plus 8 is nothing but quotient some quotient multiplied by x minus 2, because that is what we are dividing with, plus the remainder. And therefore I want to make this term as 0. So I will equate x minus 2 to 0, which means x will become 2. So how I will make it 0? By putting x is equal to 2. If I put x is equal to 2, I will make x minus 2 as 0, and this entire term will become 0. And in that case, since I have made x as 2, I will uh, put that value of x in this polynomial also, and that should be equal to my r, which is the remainder. So we will do that. We will put x is equal to 2 in the expression 3x square, which will make it 3 into 2 square plus k into 2 plus 8. And this is nothing but my polynomial, or sorry, this is nothing but my remainder. This is nothing but my remainder when I divide this polynomial with the linear polynomial x minus 2. The given polynomial with the linear polynomial x minus 2. I should get this as my remainder. And it is told here that the remainder is coming out to be 3. So this is nothing but 3. So therefore, the expression that comes out is, this will be 2 square 4 into 3, which means it will be 12 plus 2k plus 8 is coming out to be 3. So therefore, you can see here 12 plus 8 is 20 plus 2k is coming out to 3. And so if you send 20 on the other side, 2k will be 3 minus 20, which means it is minus 17, right? And therefore k will be minus 17 by 2, and that will be your answer. So this is how you can find the value of k. Now this is one of the problems. Then let's pick one more problem and then we can close it. So the question can be uh, a polynomial a polynomial 5x square plus 2x plus 1 when divided by x minus a leaves remainder as 2. So we have to find a. Suppose this is the question. So again, same logic. If I make x minus a equal to 0, right? Because that is what I have to divide it with. I will get x is equal to a. X is equal to a, right? Now with x is equal to a, I can go and substitute I can put the value of x as a in the original polynomial, which will make it 5 into a square plus 2 into a plus 1, and then I can this should be actually the remainder. So the remainder is nothing, but it is already given in the question that it is 2. So therefore 5a square plus 2a plus 1 should be equal to 2. Now if I bring the 2 on the other side, it will become minus of 1, because 1 minus 2. So it becomes minus 1 is equal to 0. So we can solve this with whatever method you want. You can solve it with this is a quadratic expression. I'm not sure if you're already aware about the quadratic expression, but it can be solved using the quadratic expressions. So I can use here directly the formula in order to solve it. So a will be equal to minus of b, which means minus of 2 plus minus root under b square. B square will give 4 minus 4 into 5a and into minus 1 by 10. This would be the value. Obviously, you can see here that it will come to minus 2 plus minus root under 4, and this would become plus here 4 plus 20. 4 into 5 is 20 by 10. So it will come equal to minus 2 plus minus root under 24 by 10. So we can leave it at this stage itself. The point was that I was just trying to explain you how you can get the value. Doing the calculation is fine. We can do that calculation. But the point is that you will make x minus a equal to 0. You get x is equal to a. And then when you substitute back into this expression of the polynomial, you are basically going to get the remainder part of the remainder of this expression, and that's what we did. We equated x minus a to 0, we got x is equal to a, and then we put it in the polynomial, in the original polynomial expression, and we have got the value as and equated it to 2, and thereafter we can solve for a. So with this, I would close this demo class for class 9. And obviously, we can do much more problems and go in more depth as we do the online classes, or if you attend uh, our offline classes, or whether you join through our online course. Even if you join, you can always reach back to us at any point in time. You can write to us, you can call us, and you can visit our website for any sort of queries that you have, and we will be more than happy to help you. So signing off for now. Keep studying and keep doing the fun and keep doing the great work that you are doing. So yeah, bye for now. Thank you.